Hello, grade 11s. So today we are going to finish off those 5.5, the normal distribution, part 2 notes from last class. And last class we were talking about how to determine if data that we are given or that we collect experimentally fits into that normal distribution set of criteria. Last class we talked about how to do that graphically. And although graphically didn't give us a confirmed yes or a confirmed no, it was able to tell us if it was likely to be classified as normally distributed or unlikely to. And how we did that is we plotted the data in a histogram. And then we said, okay, does that histogram meet the criteria that a normal distribution curve should follow? Where the mean is kind of in the middle, same with the mode median. And then we have kind of a curve where the graph tapers off on both ends. It goes up and peaks in the middle. And it's roughly symmetric-ish. So we said that, yeah, you know what? Based on this histogram, it is likely to be normally distributed. But how do we know for sure? And the way that we can do that is by determining that algebraically. So this is going to be our go-to method of how to determine if data is normally distributed or not. And what we're going to do is, if you remember, we are going to use the information of the normal distribution curve and those percentages. So the key thing here that we're going to use is that if data is normally distributed, it follows this nice bell-shaped curve, but specifically, we are going to see if our data also has 68% of data values lie between one standard deviation below the mean and one standard deviation above the mean. Remember that our mean is going to be that smack dab in the center kind of point. And one standard deviation below is going to be here. And one standard deviation above the mean is going to be there. So we are going to find the mean. We are going to find the standard deviation. We are going to find these endpoints, one standard deviation below, which is this guy. Oops, which is this guy, and one standard deviation above. And then we're going to say, hey, how much data actually falls between those values? Is it 68%? Is it way more? Is it way less? And if it's around 68%, then we're going to be like, great, this is normally distributed. If it is not close to that 68% point, we're going to be like, no, this is not normally distributed. So that's going to be our tactic, our goal, our whole purpose here. So let me get rid of this, maybe shrink that down for now. We're going to look at an example and see what the steps are to achieve that. So for starters, our first goal is going to be to plug this data in a frequency table, it's not a frequency table, into my calculator as a frequency distribution. I know that the shoe sizes here represent the data values and the total number of students represent my frequency. So when I go ahead and try and find that mean and that standard deviation that we've already learned to do, we are going to go plug that into our calculator. So we're going to go to Stat and Edit, get to L1 and L2. Of course, my data values go into L1 and my frequency goes into L2. Take a moment, pause the video, plug those data values into your calculator and determine that mean and that, come back here, and that standard deviation. And can you do that to 2 decimal places? Okay, pause. And we're back. So hopefully you went ahead and you determined the mean and the standard deviation to 2 decimal places. I was able to calculate the mean of 7.72, and I was able to calculate the standard deviation to 1.74. If you did not get these data values in your calculator, question to ask yourself is, did you make sure if you're a TI-83 that you plugged in one varstats L1, comma, L2? And if you were on a TI-84, did you make sure that your list was L1 and your freak list was L2? If not, then you might have found that the mean was 8 and the standard deviation was much smaller. All right. Okay, so now that we have those pieces of information, let me kind of clean this up a bit. We are going to find kind of these endpoints. And if you remember from our normal distribution curve, the mean is in the middle. So we know that the mean is 7.72. That is the data value from our data that is associated with the middle. This endpoint on the left, we know that every one of these lines is one standard deviation lower than the mean. So this line here can be found by taking the mean and subtracting one standard deviation, which is 1.74. And we end up with 5.98. Similarly speaking, we can go ahead and find this endpoint that we're looking at. And we know that each of these kind of dashed lines represent one standard deviation or one more standard deviation above the mean. So I could find this endpoint by taking the mean and adding one standard deviation to get 9.46. Now that's actually our next step of what we have to do next. We have to find those endpoint values. And we've already calculated them. So I know that this one, I mean minus one standard deviation is 5.98. And I know that my mean plus one standard deviation is 9.46. Again, the reason that we're calculating these two values and why they're important is because we want to see if 68% of the data falls within it. And if it does, we can say that it's normally distributed because that is one of the properties of a normally distributed graph. Okay? All right. The step after that is we are going to label these values on our curve. So again, our mean goes in the middle. I'm going to label these kind of sideways here to make sure that they fit. So I have my mean of 7.72 going smack dab in the middle of that normal distribution curve. One standard deviation below that was 5.98. And one standard deviation above that would be 9.46. Again, just pulling the values that we calculated earlier. Our next step, once we've gotten to this point, we need to now determine how many values fit within here and what that percentage it represents. So we'll need to do 3 things total. First, to find the percent of something, we need to know what that denominator is, right? Kind of like if you wanted to know what percent you got on a test and you got a 16 as your score. Well, you can't figure out your percent unless you know what the test was out of. If it was out of 16, well, great, you got 100%. If it's out of 32, well, you got a 50, right? So we need to know that total number that it's out of. And the total number that it's out of is how many data values we have in our data set. Now, we know that we're given a frequency distribution, this thing here. We're given a table that's told the data values and the frequencies. Now, that second column, the frequencies, represents how many students had a shoe size of 5, or 6, or 7, or 8, 9, 10, or 11. So to figure out how many students were surveyed, the total amount of values in the data set, we are going to add all of those numbers together. 49 plus 94 plus 118 plus 92 plus 60 plus 65 plus 40. It's every single data value within that data set. And that should give me an answer of 520. So there was a total of 520 students that were surveyed. That's the denominator when I've determined that percentage. Now, when I want to figure out the numerator so I could calculate that percentage, I actually want to know how many of those 520 fit between these two markers, between 1 standard deviation below and 1 standard deviation above. Well, that's how many people have a shoe size bigger than 5.98, but smaller than 9.46. So we're going to find the total amount of data values that lie between those two numbers. Okay, so I'm going to write down what we're looking for. Total number of data values within 1 standard deviation of the mean. So again, those are the number of data values that are between 5.98 and 9.46. That's how many students have a shoe size that's bigger than 5.98 and smaller than 9.46. Now I could look at my frequency distribution to figure that out. So when I'm taking a look at this, I have the shoe size of 5 and there's 49 people. But they do not fit in this range here because they are not between 5.98 and 9.46. So I don't care about these 49 students because they don't fit within that range. The 94 students that have a shoe size of 6 do fit in that range because they're between the shoe size of 5.98 and 9.46. Similarly, these 118 students that have a shoe size of 7 fit within that range. Same with these 92 students who have a shoe size of 8, and these 60 students who have a shoe size of 9. But these 65 students do not fit in the range because they are over 9.46. Same with these 40 students, they do not fit in within that range because they're over 9.46. So when I'm looking at the total number of students within 1 standard deviation of the mean, I'm looking at a total of these 4 numbers added together of 94 plus 118 plus 92 plus 60. And when I add all of those together, I should get 364 students. And that becomes the numerator. What I'm saying is I have 364 students that fall within this range out of a grand total of 520 students that make up this whole range. So I want to find out if 364 is around 68%, which we would expect of a normally distributed curve, out of those 500 students that were total in the survey. So again, when we find percentages, we take that total that we've calculated, that 364, and we divide it by the total of number of people surveyed, that 520. Of course, if I went and was calculating a percent on a test, again, we'll take 16 as an example. If I said 16 over 16, I know I got 100%, but 16 divided by 16 is 1. It's not 100. That's because whatever answer we get, we have to multiply by 100%, right? Because when we divide to find that total score, we're given a decimal value. Right? If we got 16 over 32, we'd get 0.5. Okay? We have to multiply that by 100 to determine the percentage. So when I go ahead and divide 364 divided by 520, I get 0.7. But when I times that by 100%, I get 70%. Now, if I'm taking a look at this, my end goal, right, remember, was to determine how much percent falls within 1 standard deviation of the mean. And If it's normally distributed, we said it has to be 68%. Well, because experimental data is never gonna be perfect, we have a little bit of wiggle room. And that wiggle room is well defined. That wiggle room says that if our calculated data percentage, the one that we just calculated, the 70%, falls within 4% of either side of the cutoff to be considered normally distributed. So what that's saying is if I get a percentage like I did here of 70%, as long as it's within 68% plus or minus 4%, so that means as long as it's between 64% and 72%, we will say that it is within the acceptable range. We will say and classify that data is normally distributed. But as soon as we calculate the percent of data values that fall within one standard deviation of the mean, and we say that it's 63.98%, that is too small. Or if it's 72.0001%, that is too big. It has to be between or including 64% and 72%. Nothing smaller than 64 and nothing bigger than 72. That is the acceptable range. So, to conclude, we in this example said that we found that 70% of our data values, the 70% of our students surveyed, have a shoe size within one standard deviation of the mean. And 70% falls within that acceptable range. So we can conclude that our data would actually be normally distributed. So we would say, yes, our data is normally distributed. Because approximately 68% of data falls within one standard deviation of the mean. And that's how we determine algebraically if something is normally distributed or not. Okay, pause this video if you need to write down the last little bits. When you're done pausing, I am going to quickly summarize the steps for us. Because we went through this, we maybe mostly understood how to get it done, but I want to make sure that we can understand the process. Okay, pause the video. Okay, hopefully you're all caught up with everything that needs to be written down. On kind of the side here in the margin, you don't have to write this down if you don't want to, but I'm just going to recap the steps that we took, just to make sure we're all on the same track here. To recap, this is what a normally distributed curve looks like. I know a couple of things about that normally distributed curve. I know that the mean is in the middle there. This left marker of the mean is one standard deviation below it. This right marker over here is one standard deviation above the mean. And I know between those two outside markers, that's 68%. That's the dream. So step one is going to be to find the mean of our data set and find that standard deviation. And our calculators can find that for us as long as we plug those lists in. So step one, find the mean and standard deviation of our data. So that's going to be our first step, and it's really crucial that we know how to plug this into our calculator properly. Because if we plug it in incorrectly, all of our calculations are based on these numbers. So take some extra time, double check what you plugged into your calculator, make sure you've got it so that the rest of the calculations can follow suit. Okay, step two. Step two was to determine the values of those outside markers. So what is one standard deviation below the mean? What is that actual number now that we know the mean and the standard deviation? And what is the value of one standard deviation above the mean? So step 2 is going to be calculate the one standard deviation range about the mean. So that implies that we are calculating what x minus one standard deviation is equal to. That's the lower bound. And what, not x, x bar. And what x bar plus one standard deviation would be. That gives us that lower boundary and that upper boundary in which 68% of the data must fall between. Step 3. Step 3 is really just going to be us determining that percentage. For our percentage, we have to find the denominator, we have to find the numerator, we then divide and multiply by 100%. Okay? So to find the denominator, we find the total number of data values within our data set. And how we do that is we add all of our frequencies together, not the data values, the frequencies, how many people have responded to each number, and add those values together to determine how many people we have surveyed in total. So we are going to add all frequencies together to find total number of data values. How many people we've surveyed. That's going to be the denominator of our fraction. Denominator. So add all frequency values together to find the total number of data values. That becomes the denominator of that percentage calculation. Step 4, we have to find the numerator. So the numerator, remember, is calculated by, again, adding frequencies, but not necessarily adding all of them. Add all of the frequency values that have a data value within the range we calculated earlier. So for us, we said that the data values had to fall between 5.98 and 9.46, and that was when you had a shoe size of 6, 7, 8, or 9. But we add the frequencies together. So, here we go. We are going to, for finding our numerator, we will add frequency values only for the data values that fall within the range calculated in step 2. Calculated in 2. So in step 2, we calculated what x bar minus 1 standard deviation was and what x bar plus 1 standard deviation was. We are going to see which data values fall within that range, and then we are going to add the frequencies together. That is going to be the numerator. Step 5, once we found the numerator and the denominator, we're going to determine the percentage. So determine percentage. And that's just taking my numerator, dividing it by my denominator, and multiplying it by 100%. So that value found in step 4 divided by that value found in step 3 times by 100% and classify as normally distributed or not. And again, how we classify that is that if it falls around the 68% mark, so either up to 4 below, 64%, or 4 above, up to 72%, and anywhere in between that range, it'll be normally distributed. If it falls below or above that range, it is not normally distributed. And that's it. So 5 steps, and we can figure out if something is normally distributed or not. Now, something to keep in mind when I ask you a question, and I believe you'll see something similar to this in the homework, if something is normally distributed or not, in the notes, yes, I have broken it down, so I kind of walk you through step by step. But if this were a real question on a homework assignment, on a test, something like that, your question would just have this. It would just say, determine if this is normally distributed or not. And all you would be given would be that frequency distribution. So you need to make sure you understand the steps, why we're doing the steps, and how to, make sure you've gotten through all of the steps and can make that final classification. Okay, that is it. Thank you for listening. And please complete the practice that follows this lesson. I hope you have a really great rest of your day. Ta-ta for now.